Alright, let's do this problem, which is the last one for this inverse section. So let's keep it going. Minimum interval to include each query. You're given a 2D integer intervals where intervals of I left to right describes ith interval starting at left and ending at right. The size of an interval is defined as the number of integers it contains. Formally, right minus left plus 1. Okay. I don't know why why is there plus 1? Like, okay. For example, if it's the, like, 1 through 4. One, two, so like 1, 2, 3, 4. So if it's 4 minus 1 equals 3, plus 1, there are 4, plus 1, which is 4 integers. Okay, makes sense. Yeah, there are 4 integers. Okay, makes sense. Size of integer is defined as the number of integer it contains. You're given an integer queries, right? Queries. The answer to the jth query is the smallest interval of I such that left of I is if there is -1. Okay. Okay, let's try to understand what an example looks like. So we have this. These are the ranges. The queries are processed as follows. The interval 2 to 4 is the smallest interval containing 2. Containing 2. The smallest interval containing 2. As follows. The queries are processed as follows. So query number 2. The interval 2 to 4 is the smallest interval containing 2. Okay. 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 The answer is 4 minus 2 plus 1. Yep. Okay, makes sense. Okay. Okay. Query 3. The 4 minus 2 plus, so the size. Okay. Compute size. Query 3. The interval 2 to 4 is the smallest interval containing 3. The answer is 4 minus 2 plus 1, or 3. The interval 4, 4 is the smallest interval containing 4. The answer is 4 minus 1, 4 minus 4. Okay. Okay. I have an idea. So we should have this. We should have a kind of a heap that stores the size of the interval. Heap that stores the size of the interval. Right? So we'll have this, the size of the thing. So it'll be 4, and then we'll have the range, which is 1 through 4, right? And we'll have it like sorted. And basically for every query, pop up the smallest size, check if it's in the range. Otherwise, if it's not, then put it back in the thing. Oh shit. I don't want to. Now that kind of ruins my theory. So I was gonna say put it back in the thing, but it's just gonna infinitely pick that one. That doesn't make any sense. I just need to figure out how I can find the smallest one. Is the queries ascending? Ah, okay. What if we sort by the size plus size plus, and then maybe like tuple size as well? Maybe I'll have like a sorted set. Like I'll just keep popping off till I find the guy I want. I don't know. I feel like I'm missing something here. I want to use a heap, but it might be a little bit too complicated. Cause I could miss something. How could I improve this? Okay, this is tricky. I'm not sure where I can go from here. The interval 2 to 4 is containing is this. Yeah, I want to sort by the size of the intervals, and then keep finding the smallest one. How many squares? Yeah, that's kind of brute force. I think this is a brute force. Is to sort by size of interval and check if it's in the range. Check if the query is in the interval range. I want to say interval, right? Thing is, I have to do that for every single query. So like, it's like n squared now. Like for every query, I have to go through possibly through the entire intervals list, which could be n. Let's just say there's n queries and there's also n intervals, and I have to go through for every query. I have to possibly go through every single interval because I'm not finding the right one, you know. So that is brute force. And plus on top of that, I have to sort it, which is another like n log n type of situation. And then, so it's n squared. But n squared gets taken up by how bigger it is. So that is n squared. I don't think... I think we need to figure out a way to optimize this. I mean, if I do sort it, what if I sort the queries as well? If I sort the intervals and kind of prune results, so like, okay, for example, like query, I don't know, there's no point in checking like results that are like way too big, you know? Like if the ends are bigger, actually if the star is bigger than the query, no need to check that forward and beyond. So that could actually be an optimization. So yeah, let's go with our plan and prune any results that are like, you know, there's clearly not a chance, you know? Okay. But that assumes if I go through the intervals sorted, you know? So like for every query and for every interval. Okay, so I have an idea. So we can have a map of the size. Well, let's do this. Let's have a map of the size. So we'll do default dict. Shoot. For every query in queries, do something. For every interval in intervals, for every interval in intervals, well, actually, I just do this. Actually, yeah, I do need to do that. But let me intervals dot sort this. All right, I don't know why that actually happens. We'll do map of interval. I guess we can do a tuple. Interval equals, that's actually an integer actually. And which is actually start and peel that apart, and we'll do end minus, let's be more, let's do right, that's actually left. Right minus left plus 1. I assume that the intervals are unique. Is that true? Yeah. And we'll iterate through for every query in this, right? We'll do obviously res here. Return res. And we hash it. Query. query is just basically a tuple. And then, oh, no. Oh, wait, I'm stupid. Yeah, this is fine. Query, tuple for every interval in intervals. I don't think we'll prune, like, we'll stop searching. Like, for example, so we'll do left or right equals interval, right? We'll stop checking after that point and forward. Okay, so res of query. Okay, hold on. Let me. What am I doing? Think. Okay, so we have here hashed query, and then we can look it up now. Okay, this is here. Hashed interval. Right? Interval. And then we look at the map of hashed interval. First though, I'll peel this out, right? Ah, shoot. Left right interval. First off, if the query is if the left is bigger than the query, no point in checking and beyond. We'll just do res.append -1 because, like, this is only gonna get bigger from there, right? Yeah, because the start is most important, you know. So yeah, so it's not gonna be, I guess worst case could still be really bad, but I'm just trying to think of any other optimizations I could do. But out of the way, let's assume that it's not. It's probably in the range somehow. We'll get the map and we get the size and res.append size. So let me really think that this is pretty brute force. But anyways, we go through the intervals, take the left and right, take the actual tuple and assign. I hope that they're different, bro. But anyways, right? So we're sorting them by that, and also mapping their size as something important. Okay, so now, yeah. Now what? So now we go through the query. So we'll go through 2. Now let's go through the intervals. Check if 1 and 4, so the hashed interval, so 1 through 4, so that will give us 4. First checked left and right, which is going to be 1 and 4. Right? Check if the left is greater than the query. So is 1 greater than that? No, it's not. So it's possibly in the range. So get the size. Wait, I should probably do a check first. If left less than equal to right, query. Oh yeah, and then we should probably break out of here too, because we want to stop as soon as we find the first instance, right? So prune, like, don't even check any further. If it's neither of these, meaning it's not in the range, keep potentially going, but not too far, right? Anyways, we go in the range. I wouldn't say. Yeah, that's fine. Yep, and then so let's say, for example, 2, 1 through 4 is that, and actually Ah, shit, no. We're not supposed to go by the smallest interval. We're supposed to go by the smallest size. This is why we have to go through the size. Ah, shit. Fuck, 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 fuck. Okay, we messed this up. Alright, let's start over. I want to go through the intervals by their size. Sorted key equals their interval map. Tuple. I don't know why this keeps freaking popping up. Is there a way to just not have this up? GG's, boys. All right. Could we do that? Yeah, let's actually, hold on. Let me sort this by, let me just, actually don't even need to, wait. Key equals x lambda, where x is, we take map of tuple x. Yeah, and then we don't even need to do this. We'll sort by hold on, return print intervals. So theoretically we should have 4 minus 2 shit, 4 minus 2. Let me see this actually. Alright, what about this, boys? 4 4 2 4 1 4 3 6. Alright, perfect. Okay, that's exactly what I wanted. So I want you to sort by their size instead. Okay, now we go through their for intervals and intervals. Take that. We're making another optimization, which is the left, to the left. No, don't do that. We're actually not necessarily sorted by their range, so we're sorted by their smallest key. Yeah, I still think this is gonna be, this is the only optimization I have, which is just to stop if it's not, well, no, 10, yeah, it is. It's to stop as soon as you find an answer, which is still bad, but I think it could get us the answer though. Okay, never mind. Oh, wait, I don't have a case where let's give a flag, I guess. If not found, res.append -1. It works, but I don't think it's fast enough. Yeah. What could be the optimization? Because I feel like that's repeated work. Yeah. Not repeated work, but there's just something I can just not check. Like, I know that one optimization was like the intervals, you know? Like, are you even in the right range, you know? So I'm trying to, this is like maximizing the size, you know? But if I maximize the range, I can also prune results. Could I combine the both? If I maximize the range of where I'm looking at, Let me think about this. If I maximize the range, of where I'm going towards, right? I just realized something. If I maximize the range, would that change the difference? Yes, because just because you find the reason why I have to maximize the size is because I can actually 2 fits into both of these or both of these, but I picked this one because this has a smaller size than this. Okay, I think I can hold on. I can utilize both. Hold on. I think I can utilize both. I should keep going as long as I'm in the range, and then update only if my score, meaning the size, is smaller. Got it. So I should keep track of the. Okay, I should basically sort by interval. Go through each interval. And then let me rehash this logic real quick. So for every interval in intervals, let's optimize for range. Or not range. Yeah, the range. So basically, give me back this. Oh, no. Fuck. Okay, whatever's. Okay. So for every interval in intervals, if, come on. So let's do this. Left, right, interval, right? So if we first check, we can prune results. If left is greater than right, there's no point, or not, left is greater than query, there's no point in checking, so just get out of there, right? And we could do if not found, res.append -1. Simple stuff. Pruning results that are just way too like pointless to check, then keep going, right? If you're in the range, keep going. So basically, if left of less than equal to query, less than equal to right, oh fuck, then res.append. Actually, there's not even point. Actually, it's fine. We can say found equals true, right? But we can keep going though. Res.append, right? We'll append. Shit. Hold on. Let's do this instead. Let's do have size equals this, right? We'll assume -1. And we'll do size, right? Instead of doing this, we'll do size equals the map of tuple of interval, right? And right. And only if, only if size is greater than or less than what you're looking up right now, right? Yeah. Or I don't even care about this. Just give me the smallest. Yeah. Oh my god. Bro, I'm clicking something. I keep fucking like what? How do I get rid of this stupid thing? I don't even know the keybind for that. I just accidentally press it. Okay. Anyways. Yeah. Take the smaller one, which is you're in the thing. Oh yeah, that's potentially an answer. right? And we also prune results that are like there's no point in checking further on if you're not going to be even close to the range. If like the start is not even in the query, like you're potentially in range if the start is at least smaller than the query or equal to. I think that can help. Okay, let's try that. Okay, I got the wrong answer this time. GG. Oh no. I need to make sure of the one thing. If size does not equal -1. Else. Well, I should make this float. And then this will work. And then if size does not equal equals float, size equals -1. So res.append size. Okay, pretty straightforward. Yeah. Okay, faster? No, not enough, boys. GG's. I don't know how I can optimize this. Like, it's so freaking annoying. It's really annoying because I'm still am potentially like if I can't find it, it'll tell me sooner though. No. Yeah. I should know. Oh no. Is the queries not sorted too? Can I sort the queries? I don't think so. The queries have to stay the same because they're mapped to the same thing. I don't think sorting queries matters. What if I instead like did binary search within the instead of iterating through every single one? Maybe that could help because I'm going through every single one. I feel like this could help. Let's do that. So let's do while L less than R to L R length of intervals. So basically, if could I do binary search like okay, from here to here, where should I kind of look towards? I should definitely look towards here if I'm going through 2, right? Yeah, let's do binary search. That might help with optimizing it. So binary search will definitely help us find like the general range. Maybe I should look at bro, I don't know. Okay. What would I try to look for? I wouldn't definitely try to look for the number 2, right? Like this could potentially be smaller too, right? You know, like 1 through 2 and 2 through. It doesn't matter, I guess. I guess if so, we can do mid L plus R. To if m res of okay, so if intervals of m. I guess we can do the query here. I mean, now we could do the start of the query, like the left. Sure, we can do that. And then we could do, well, I guess we will need like, I still want to do, what should it be biased towards? Like, I don't know. What should I do here? Maybe I should start. Maybe should I go back to the. Maybe I should. Maybe I should do the. I should go back to the heap idea. So the idea is go through the query, right? So we should go through the query, add in all the intervals that is in the query range, right? And then put the heap inside, put the heap sorted by the size, and the top of the one will always be your value. Okay, I think that works. Like, yeah, I think that works. We don't need a map here. Let's restart. So let's do this. So let's do this. So we have a heap here. Well, actually, no, we do that later. Let's do this. Let's do res here. I'm gonna fill this up with. How should I do this? I feel like does the order matter? Okay, since it matters, I'm gonna do this. Res equals this. I'm gonna do that, and then I'm gonna do indexed. For every let's do indexed queries. So we'll just do which is just for. I think we could do the query and then the I for query. Enumerate queries like that, and then print indexed queries. Perhaps I got no. What? A comma? Oh. Wait, isn't this the syntax? Do I do this? I don't think that's. Yeah, that doesn't make sense. Wait, what am I missing? Perhaps I forgot a comma. Wait, what? List comprehension. Expression for item if. No, I'm not tweaking, bro. Alright, fuck this. Let's just do this. For every I query, enumerate indexed queries. The append the query and I think we should also go to the smallest so that we can, yeah, let's do that. So now now we can put them back in their original spots. This time now we have this. So we'll have like a very query in queries. Oh my god, I can't spell. Let's go through them sorted. Then we will make a heap. While the query oh, there's intervals. Oops. Okay, while I, so let's have I here. We'll do I is less than length of intervals. And the the intervals of I at 0, meaning the start, is less than or equal to query. And if it's possibly in the range, then add it to heap. So we'll do heap push the heap, and the value of the we'll do this start, it's not start, it's left right equals intervals of I. Yeah, there you go. And then we'll do right minus left plus 1, then query. Easy peasy. Do I even care about the query? Oh, I do. Because the query... Oh, no, I should go through... No. I should go through indexed queries. Yeah, I don't really care. Oh, I do need the query. No, what am I doing? Yeah, query. Yes, I do need the query and I. Yeah, I need those together. Yeah, I need this together. But I want them sorted by the I want them sorted by the size. Okay. Then while so in the heap, the top is the smallest. So if not heap, if there's nothing, then don't do anything. Just leave it as be. If there is something, then we'll do this. Heap pop size info size and Q. Can I do this? Val query val and index. Heap pop the heap, then res of index equals val. Done. I guess I can flush everything out while heap. Return res. Can I? Okay, does this work? Ah, shit. I forgot to do this. No, I messed up. Oh no. I plus, yep, and then I should keep query of 0. Yeah, the actual query. Okay, now that's fine, and then we can keep the actual query. Okay, there you go. And then size, val, index, and then index, val, yeah. Yeah, that's true. Of 1 to cube of 0. I don't know if that works, to be honest. Did I put it wrong? Query. Oh, wait. Wait, is this right? Yeah, that's fine. Sorted index queries for every query. And this and this. Intervals of I. Left and right. He push right when it's left plus 1 and put the query. Am I not putting the right fucking values? No. I feel like I'm close. Come on, man. Do I even need this? I'm getting completely wrong values, so this is technically wrong. Okay, so for intervals of I, query of 0, left to right intervals, she push right minus left plus 1, query I plus. Oh no, I should also go through. Wait, give it back. I should actually do this and check if the heap of 0 and 1 is greater than q. Yeah, I should also do this. I should remove the ones that also the right side is not good. I should also keep, now instead of this, I should keep the right. And this will give me what I exactly need, which is just actually size. Size there, and then I, and then size. I think I should do query query and then Q and I like this, and then enumerate, bro, enumerate. What that, bruh, it keeps happening. Oh, I got it flipped. Oh my god, this is getting confusing. Hold on. I should iterate through for every QI and Q. Or it's... Yeah, it's fine. Yep. QI or Q and QI in sorted indexed queries. Then heap while I less than intervals of I and less than equal. And this is wrong now. Okay, so now I have to say query, not index, query. Yep. Right. Yep. And then I have to get the size, which is... Honestly, I could just do this. The first value, which is the size. What? Yeah. Raise of I equals size. Also check if the ending range is also bad. Does this work? Oh, wait. No. This is QI. There you go. Better? No, it's still TLE, bro? That's kind of insane. Oh, this is wrong answer. What the fuck? What am I doing wrong here? Wait, let me remove this heap out. Let's just make a global heap. What? Why is this taking forever? How is this a wrong answer? Yeah. Oh my god, I forgot to do this. Intervals dot sort. Oh no, yeah, because we need to sort them by... We need to sort... because we are assuming that we're going linearly. Oh my god, I got a TLE again. What am I... I feel like this is not that, like, off. Memory exceeded? I've never gotten a memory exceeded. Do you care about the output then? Because I could just simply do this. Or, I could just do this. And I can just go through queries. We could just go through. Yeah. If it don't care about the index, then that saves me a lot of memory. And I wouldn't even need this. And I don't even need this. Yeah, that would save me a lot of memory. If it could just, yeah. Oops. Where am I getting that -1 from? Oh, I forgot to do if not heap, then else. Yeah, there you go. So they do care about the order, bro. I have to store the order somehow. Wait, why? Okay, I should not be doing this. I should just keep going. Like, if I'm going by sorted, then I would want to be going towards like yeah, this would, I should stay at the ranges, you know? Ah, no, I get something else. I feel like hold on, I think I'm getting somewhere. Give me 3 instead of 4. I mean, she gave me 3 instead of 4. Super close. Hold on. Done the size calculation correctly and heap of that. Yup. Sorted index. Like, let me make sure that it's lambda. So key equals lambda. I'm gonna make sure that it sorts by the starting. Okay, I don't think that makes a difference, to be honest. But anyways, if it doesn't make a difference, I'm gonna change that. So we'll do this. Query indexed and intervals of I of the left side, which is the query. Oh, no, not the query, which is the start. Less than or equal to query. Take the left and right. Heap right, left, -1 plus. Then we put the right. Then compare the right. If it's in the range, pop those out of there. Then the left remaining one, it will be the size, which is the first index. Then we set the Q of I to this equals the size, and it was already -1 though. Why would it even matter? I don't think that makes a difference. Yeah, it doesn't. What? No. I'm missing something else. Do I need to pop? I don't think I need to pop. Let's just take the top of the value and let's do that. What does that make a difference? Because we're gonna always be popping stuff that are not necessary, you know. Yeah. Okay, perfect. All right, see you guys tomorrow.